In this lecture, we'll discuss regarding transfer of heat energy as through radiation, conduction, convection, then latitude heat balance. So, the heat energy from the solar radiation is received by the earth through three mechanisms. So the first mechanism is radiation, which means wide transmission from one body to another. It is possible in relatively empty space, for instance, from the sun to the earth through space. And the second important mechanism of transfer of heat energy is conduction, which means through matter by molecular activity. Generally, denser materials like water are good conductors, and lighter medium like air is a bad conductor of heat. And the third one, that mechanism is called convection, which means transfer of heat energy by actual transfer of matter or substance from one place to another. And finally, latitudinal heat balance means in spite of the heat balance maintained by the earth, the amount of insolation received varies from latitude to latitude. It decreases from the equator towards the poles at latitudes below 40 degrees. More solar radiation is received than is lost to space by earth. The opposite is true for higher latitudes, where more heat is lost than received. Going by this logic, the tropics should have been getting progressively hotter and the poles getting progressively cooler. But in reality, this does not happen. The atmosphere and the oceans act as giant thermal engines that transfer heat from the tropics towards the poles. Due to an imbalance of heat, winds and ocean currents are produced, which act as vehicles for transportation of heat energy from lower to higher latitudes, as most of the heat transfer takes place across the world. Latitudes. So now we'll discuss regarding the next important aspect, and that is relating to temperature, is humidity. So what exactly humidity means? The very introduction and the very types of humidity as absolute humidity, relative humidity, and specific humidity. That we will discuss. So humidity is the general term which describes the invisible amount of water vapor present in the air. It is a highly variable climatic factor which forms only a small proportion, varying from 0 to 4% and averaging around 2% in the atmosphere. Humidity is measured by an instrument, and that is called hygrometer. Water vapor in the atmosphere comes through evaporation from the oceans, lakes, rivers, ice fields, and glaciers, through transpiration from plants and respiration from animals show the very meaning of absolute humidity. It is the weight of actual amount of water vapor present in a unit volume of air. It is usually expressed as grams per cubic meter of air. Absolute humidity of the atmosphere changes from place to place and from time to time. The ability of air to hold water vapor depends entirely on its temperature. Warm air can hold more moisture than cold air. For instance, at a temperature of 10 degrees centigrade, 1 cubic meter of air can hold 11.4 grams of water vapor. The same volume of air can hold 22.2 grams of water vapor once the temperature rises to 21 degrees centigrade. Thus, a rise in the temperature of air increases its capacity to retain water vapor, whereas a fall in temperature decreases it. However, it is not a very reliable index because changes in temperature and pressure cause change in the volume of air and consequently the absolute humidity. And now we'll discuss about relative humidity. It is a more practical measure of atmospheric moisture. It is the ratio of the air's actual water vapor content to its water vapor capacity at a given temperature. This relationship between absolute humidity and the maximum moisture holding capacity of air at a particular temperature is always expressed in percentage. Since the relative humidity is based on the air's water vapor content as well as on its capacity, it can be changed in either of the two ways. For example, if moisture is added by evaporation, the relative humidity will increase. And secondly, a decrease in temperature, hence decrease in moisture holding capacity, will cause an increase in relative humidity. The relative humidity determines the amount and rate of evaporation, hence it is an important climatic factor. Air containing moisture to its full capacity at a given temperature is said to be saturated. At this temperature, the air cannot hold any additional amount of moisture. Thus, the relative humidity of the saturated air is 100%. If it has half the amount of moisture that it can carry, the air is unsaturated and its relative humidity is only 50 degree or 50%. A given sample of air becomes saturated without any actual change in its moisture content, provided its temperature falls or it cools to the required extent. The temperature at which saturation occurs in a given sample of air or water vapor begins to change into water is known as the dew point. Now we'll go to the next one, that is specific humidity. It is expressed as the weight of water vapor per unit weight of air or the proportion of the mass of water vapor to the total mass of air. Since it is measured in units of weight, usually grams per kilograms. The specific humidity is not affected by changes in pressure or temperature. And now we'll discuss regarding what is evaporation and what exactly evaporation means. So, in that connection, evaporation is the process by which matter changes from liquid to a gaseous or vapor state. The atmosphere, the moisture or humidity is nothing but water vapor, which has escaped from oceans, rivers, lakes, ponds, plants, animals, and humans into the atmosphere. Its energy is required for evaporation to take place, and in case of atmospheric moisture, the energy is provided by solar radiation. The water molecules supplied with this energy get the required motion to escape and conserve this energy as latent heat of vaporization. Again, when the vapors get condensed into water drops, this energy is released in the form of latent heat of condensation. So, we'll look at exactly what condensation means. So, the very meaning of condensation is the process of change. So, the very meaning of condensation is the process of change of state from gaseous to liquid or solid state. When moist air is cooler, it may reach a level when its capacity to hold water vapor is exceeded by the actual amount present in it. Then the excess water vapor condenses into a liquid or solid form depending upon the very temperature of the place. In free air, condensation results from cooling around very small particles termed condensation nuclei. Particles of dust, smoke, and salt from the oceans are particularly good nuclei because they absorb water. These particles are termed as hygroscopic or water-seeking nuclei. Condensation in air itself can only take place if the air temperature is reduced to below the dew point. As the dew point of any mass of air is its saturation point when its relative humidity is 100%, a little more cooling will bring the point to the level where condensation takes place. When water vapor changes into clouds or rain, in contrast, when the relative humidity is low, a large amount of cooling is required to first reach the dew point and then the condensation. Condensation therefore depends upon the amount of cooling and relative humidity of the air. Condensation occurs under varying conditions which in some way or the other are associated with change in any of these variables such as air volume, temperature, pressure, and humidity. And now we'll discuss the very forms of condensation that we found as such. One is dew, and the second one is white frost, then fog, mist, then cloud. So, among the various forms, dew, when moisture is deposited in form of water, droplets, and cooler surface of solid objects such as stones, gases, blades, and plant leaves, it is known as dew. The ideal conditions for its formation are a clear sky, little or no wind, high relative humidity, and long, cold nights leading to greater radiation of heat from the earth for its cooling. For the formation of dew, it is necessary that the dew point is above freezing point. And the second form of condensation is white frost. When condensation takes place at a dew point which is at or below freezing point, that is 0 degrees centigrade, excess moisture is deposited in the form of minute ice crystals instead of droplets of water. It is called white frost. The ideal conditions for formation of white frost are the same as those for formation of dew, except that the air temperature must be at or below freezing point. And the next form of condensation is fog. Fog is defined as a cloud with its base at or very near the ground. Fogs are of different kinds depending upon the nature of the cooling process. Radiation fog results from radiation cooling of the ground and adjacent air. These fogs are not very thick. Fogs formed by condensation of warm air when it moves horizontally over a cold surface are known as advectional fog. These fogs are thick and persistent, sometimes due to convergence of warm and cold air masses. The warm air mass is pushed out by the heavier cold air mass. Then, if the warm air reaches saturation and some moisture falls down as precipitation, this moisture falling as precipitation may condense to produce fog at the boundary of the two air masses. These are called frontal or precipitations fog. Then the next form of condensation is mist. This is also a kind of fog in which the visibility is more than 1 kilometer but less than 2 kilometers. And finally, the last form of condensation is cloud. A cloud is a mass of minute droplets of water or tiny crystals of ice formed by the condensation of the water vapor in free air at considerable elevations. So, these are the different forms of condensation as we discuss under the head condensation. And also in this lecture we have discussed what humidity means, and also the very introduction of humidity As such, absolute humidity, relative humidity, specific humidity, and also regarding transfer of heat energy through radiation, conduction, convection, and latitudinal heat balance, then evaporation, the very meaning of evaporation. So, in our next upcoming lecture, we will discuss the remaining portions of atmosphere.